Okay, so this morning we're going to look at how we display data on a stem and leaf diagram. So we've already collected our data, which is our birthday, so the day and the month that we were born. And we're going to now transfer that data onto two different stem and leaf plots. So let's draw the first one. Okay. Now, if you remember from last year, we did do stem and leaf diagrams last year. Two separate columns. The first column is your stem and the second are your leaves. So how many stems will we have? Be careful, it's a bit of, you've got to think this through. How many stems will we have, Matt?
12. Is it odd?
No. Tyler?
Other stems and then like the amount of like.
Yeah, so how many will there be? Owen? 4, well done. The first stem is going to be 0. The second stem is going to be 1. The third stem is going to be 2. And the last stem is going to be 3. Now, what do those stems represent? Because I've got a few people looking at me as if saying, huh? What do they represent?
The tens column.
The tens column, that's right. So the first one's obviously 0. Because if we've got a number below 10, there isn't anything in the tens column. So we have to put a 0 there to show that it is a unit below 10. This 1 represents a 1 in the tens column. This 2 represents a 2, 20 in the tens column. And the 3 represents a 3, 30 in the tens column. Now, there are various different ways of transferring that data onto here. If you wanted to, you could do it numerically and start with all the ones below 10. What I'm going to do is I'm just going to literally transfer the data over. This is just a normal stem and leaf diagram. It's not ordered, and we'll do that later. So, as I said, main error is human error. So when I deal with one of these bits of data, I need to indicate to myself that I've done it. So you can either cross it out or put a little tick next to it. Okay? So 8 will go here. Because obviously we've got no tens, 8 units. 29 will go here. 2 tens, 9 units. 12 will go there. Okay? Is this ringing bells now? Do people remember? Good. 21 will go there. Now, one of the things to remember with your stem and leaf diagram is that your leaves have to be in neat columns. If you want to actually draw yourself some columns, you can, but you don't have to. Okay? 14 will go there. 18 will go there. 23, 29, 20, 10, 26, 30, 12, 19, 50, 2, 18, 17, 4, 5, 18, 26, 3, 30, 20, 6, 10, and finally number 7. Now you can see obviously that there's a fairly even distribution of numbers in the zeros, the 10s and the 20s. Why are there fewer in the 30s? Well, this is common sense, this. It's not maths, it's common sense.
Because there's only 2 days.
Absolutely, there's only 2 days in the 30s, so it's, probability tells us that there's going to be fewer people who have their birthday on that one. Really though, these should be even, shouldn't they? You know, you should, if we carried on and we did a much bigger survey, you would probably find that these sort of evened out and there would be an equal number of people who had their birthdays in the zeros and then the tens and then the 20s, because they all have the same number of options. So this is our stem and leaf diagram. Now, it's useful in some ways. It's useful in that it shows us the distribution of the data. We could now, if we wanted to, say, well, okay, how many people had a birthday in the zeros, and we just count the leaves, 7. How many people had have their birthday in the tens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. How many in the 20s? 10 also, because we know that they're the same number because they're lined up. And then how many in the 30s? 3. So it's useful in some ways. We could probably, from this, work out the range. We can definitely work out the total frequency because we would look at the number of leaves, wouldn't we? Okay? And we could find the median. Not easy though. So what we do is we make an ordered stem and leaf diagram. So that means that the leaves are in ascending order also. So I'm going to rub out my leaves because obviously I don't want to draw the book, but you draw yourself another table, please. Okay, so I'm going to rub out the leaves. Now, probably the best thing to do is, if you are going to do a stem and leaf diagram, is to do an ordered one straight from the beginning. I just wanted to show you how a stem and leaf could look when the leaves aren't in order, but it's actually much more use to you, statistically, if you put it in order straight away. So now, of course, I've rubbed out all my leaves, so I need to work out how I do it. This is the way I would do it. I would go through my data and circle all of my ones with only one digit. 6, 7. Okay, so 1, 2, 3, 5, 6, 7. Are there 7 of them?
Yeah.
Yeah, okay. So now then, what I can do is I can transfer it from there to there in ascending order. So the 1 is going to go first, that's going to go there. Then I've got a 2, so that's going to go there. Then I've got a 4, that's going to go there. The 5 is going to go there. The 6, the 7 and the 8. The 6, the 7 and the 8. So now our leaves are in ascending order. So we've got, obviously, our lowest number now we know is 1, because that was the lowest bit of data, the lowest value. Now tens, so let's have a look at this one. So we'll circle those. There were more of these, weren't there? So, bless you. Okay, so is that all of them? Yeah, so this is going to be slightly harder to do because it's now, you know, more data to look at and you've got to be a bit more careful. So we've got a 10. Do we have another 10?
Yeah.
Yes, we do. So we've got 2 zeros, okay? Okay, then let's have a look. We've got a 12. Have we got another 12? But nothing else. No 11s. So we've got a 12 and another 12. You should be able to do this much more easily because you've got the one that's not ordered. You should just be able to do it from that. Then we've got 14. 14. Have we got a 15? No. A 16? No. 17 we do, yes. Okay, then an 18. 2 18s, 18 there and 18 there. So 8 and 8 and 2 19s. There we go. Yeah, there we go. 19s, 2 19s. Okay. So what I'd like someone to do for me now is to order the 20s for me. we know that the zeros were, the threes, sorry, were just 3 zeros because it was 30th, 30th and 30th, wasn't it? Noreen, could you order the 20th for me?
0,
Yeah?
0,
Yeah?
0, 1, 3, 3, 6, 9.
Brilliant, thank you. Very good. That was a lot quicker. That's what I need. I just need, obviously, someone to do it for me. It's great. So now we've got an ordered stem and leaf diagram. This is much more useful. Immediately, we can see the range. We've got our maximum value here and our minimum value there. So what's our range? 29, absolutely. Okay. The maximum it could be is 30, of course, because 31st and 1st. So our range, let's put that up here. Our range is 29. Okay. The other thing that's useful is we can look for the mode quite easily, because obviously when we look for the mode, we're looking for leaves that repeat themselves. So what's the mode?
Maybe 30.
Well, we've got 30, yeah,
And 20.
and 20. Okay. So the mode is 20 and 30. Now, what is a data set called that has 2 modes? You're nearly there. We learnt it last year. Bimodal. Bimodal. Okay? So this data set is bimodal. It's got 2 modes. We've got 3 students whose birthday was on the 20th and 3 on the 30th.
Is the dot like between them?
No, that's just where the board doesn't... Do you remember the hole in the board? I should have drawn the line through it, but my lines aren't straight. Okay, so we've worked out the mode and the range pretty easily from our data set. Now, the next thing you probably would want to do is work out your total frequency.
30.
It's 30, that's right. Your total frequency is 30. Now, if we're going to look for the median, and we have 30 bits of data, which bits of data are going to be the median? The second and the third, or the fifth and the sixth, or which are in kind of ordinal value, which bits of data?
15 and 16.
Well done. It's going to be, so the median is going to be the 15th and the 16th bit of data, and then obviously we've got to find the average of those two. So now you know that, we've already put the data in ascending order, because that's what we did when we did the ordered stem and leaf. Now we just need to count the 15th bit of data and the 16th, bless you. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Well, the 15th bit of data's there and the 16th bit of data's there. So the 15th bit of data is what?
18.
Oh, you've fallen in the hole.
18.
You've fallen in the hole.
18.
18 and 19. It's a really common mistake, actually. Really common. That people will look at it and forget about the stems and only deal with the leaves. Because that is not 8, it's 18. Because you've got the 10 there and the 18. So, if my 15th bit of data is 18 and my 16th bit of data is 19, my median is 18.5. That's right, 18.5. So that's a really good way of using a stem and leaf diagram to help you find the median. Okay, should we stop there? Thank you.